In the video on port numbers, we left off with this picture. We said that this computer wants to talk to this server, and so it sends out a packet with its return address and then a return port number, and then this web server gets it, sends it to this particular port number, which is the port number specified by this computer, and then returns it back to this IP address and this port number here. All right, that's all well and good if this is a public IP address, which in this case it is. This is the IP address that the ISP, the Internet Service Provider, gave to this particular client. However, I said earlier in another video that usually we use private addresses, not public addresses, because there may be 100 computers on this network. And if I had to give each of them an IP address, a public IP address, well, we just don't have enough public IP addresses to go around. So we give them private addresses instead. So enter NAT, Network Address Translation, which translates between private addresses and public addresses. It looks like this. Here we have a private address. Private addresses are in certain contiguous ranges of 10 dot anything, 172.16 to 31, and then anything, or 192.168, and then anything. Those are all private address ranges. So we have a 10 dot, which is a private address range, and we want to get a web page from this server. So we're going to send out a packet from 10.0.0.1. That's the only address this computer knows, and it's not its public address, but it is its private address with the port number 54321. And it's going to send it to 210.20.30.443. All right, the router gets it. Now this router is our NAT device. This router is running the NAT service. And by the way, NAT is simply one of the protocols in the TCP/IP protocol suite. It's going to write down in its little memory here 10.0.0.154.321 is equal to 130.30.20.10.44445. In other words, it gives it a new address. This is the ISP address, the public address, and it gives it a new port number. It sends all that out. Now this thing returns, but it doesn't know anything about this address, so it returns it to 130.30.20.10.44445. Once this router receives it, NAT goes back into action, and it looks it up on its table and says, oh, that one is the same one as 10.0.0.154.321. So it translates that back to the new destination address, sends it back to the computer, and the computer's happy. Now, what does this do for us? Why do we need NAT? Well, there are 3 good reasons why we need NAT. First of all, it extends the use of IP version 4 addresses beyond its capacity. Because many computers, there can be literally thousands, and there are probably tens of thousands or millions of computers that have this same private address. And we can do that. We can duplicate the address because all of the computers on that private network are all translating to one single public IP address. The second thing it does for us is reduce cost. I don't have to purchase IP addresses for every computer on my network. If I have 1,000 computers on my network, I don't want to purchase an IP address for every one of them. So I can have private addresses all I want and only one public address. Third, it hides internal computers. Now, this was not one of the purposes of NAT, but it's a nice byproduct. That is to say, from the outside, nobody knows what the internal address of this computer is because it's hidden by the NAT device. Now, one thing I want to mention here is that this particular version of NAT is actually called port address translation. And the difference between the two is that network address translation actually is a one-to-one. In other words, there are multiple public addresses and multiple private addresses. With port address translation, you have multiple private addresses and only one public address. So the particular flavor of NAT is called PAT, or port address translation, but everybody just says NAT anyway, so we're just using the term NAT.